For this video, let's illustrate the equivalent exponential generating function together with the possible sequence of numbers and some implications for the given illustration here, where we're given with e to the power of x minus e to the power of negative x over 2. Now, this is not the usual pattern in this playlist. At the same time, this doesn't necessarily connect to some of the combinatorial problems, but we need this. We need to also understand this one, because once we came across with this type of expression, we should know how it should look like in terms of exponential generating functions, its sequence, and again, its corresponding implication. Now, let's start talking about e to the power of x before this one. We know this to be the having a power series equivalent to the summation of x to the power of r over r factorial, as r is equal to 0 to positive infinity. If we are going to break it into its form, you will have here what they call this one, x, that's actually equal to 1. Automatically, that's 0 over 0. So that's 1 plus 1x to the power of 1 over 1 factorial plus 1x squared over 2 factorial until we reach the equivalent form of x to the power of r over r factorial. Okay, in simplified form, it's just equal to 1 plus x over 1 factorial without simplifying the factorial notations, plus x squared over 2 factorial, plus you have x to the power of r over r factorial as well. Okay, we'll be using that later on in this given item. Now, let's talk about e to the power of negative x. We also had discussion with this, one of the videos previously in this playlist. Please try to browse our playlist and look for that. But I'm going to give you here the rough solution. This is actually equal to the summation of negative 1 raised to the r, x to the power of r, over r factorial, as r is equal to 0 to positive infinity. When expanded, is equal to 1. Okay, so say for example, if it's 0, so that's 1. You have here plus negative 1 raised to 1, x to the power of 1 over 1 factorial, plus negative 1 squared, x squared over 2 factorial, plus so on and so forth until you reach negative 1 raised to r, x to the power of r over r factorial. In simplified form, we can actually use it here. You have 1, then that's negative x over 1 factorial, then that's positive, plus x squared over 2 factorial, and we would expect if there are other things there such as this, negative 1 raised to 3, we also negative, so on and so forth until you reach negative 1 to the power of r, x to the power of r over r factorial. I'm talking about the possibility of having alternating signs here all throughout. That's the difference between the first form. Now, if we're going to combine them to come up with this, so this is how it would look like. Again, we have e to the power of x minus e to the power of minus x over 2. But let's start with e to the power of x minus e to the power of negative x. So we're going to subtract all of them. So we'll start with the first 1 plus x over 1 factorial plus x squared over 2 factorial plus, these are actually factorial. Let me rewrite this, factorial, factorial, plus until you reach, you have x to the power of r over r factorial, minus the second group, 1 minus x over 1 factorial plus x squared over 2 factorial, minus here plus, until you reach negative 1 raised to r, x to the power of r over r factorial, and so on and so forth. By removing the grouping symbol, we'll have this form, 1 plus x over 1 factorial plus x squared over 2 factorial plus so on and so forth again until x to the power of r over r factorial. And for the second group, since this is preceded by a negative sign, all the signs inside will be changed. So we have here plus 1 minus x, I repeat, it's minus 1 rather. It's minus 1 plus x over 1 factorial minus x squared over 2 factorial. The negative here will be plus, and so on and so forth. I will still use plus here because we don't know the value of r, or we don't know what is the rth term. So we'll have that, so on and so forth. If you're going to look at this closely, there are some items that could be removed. 1 will be removed here. This positive x squared will be removed here. I believe there's also positive x to the power of 4 there over 4 factorial, where in this case minus x to the power of 4 over 4 factorial, so remove that, and so on and so forth. In the meantime, let's not remove these two because we don't know yet the value of r. But nevertheless, if we're going to look at that, basically if r here is negative, so that's odd, this is negative, this will be positive here. If r here is positive, even, so this will be plus and plus here. That's why I cannot remove them. And nevertheless, if we're going to look at them in rth term, that number of items will still go on and some will be cancelled. Looking into that, you'll have here x over 1 factorial plus you're expecting x cubed over 3 factorial in the middle, plus so on and so forth until again x to the power of r over r factorial. Here, you will still have x over 1 factorial. You're also expecting x cubed over 3 factorial, and so on and so forth until again negative 1 raised to r x to the power of r over r factorial. Now, you have 2 of this. This will be simplified as twice x over 1 factorial plus twice x cubed over 3 factorial. If there is x to the power of 5, we're also expecting twice of that over 5 factorial until you reach this sum. Again, there's no representation for that, so let's leave the ellipsis as it is. This is not yet the final form because we are to divide it into 2. So by dividing all of this into 2, you will simply get x over 1 factorial plus x cubed over 3 factorial plus x to the power of 5 over 5 factorial, and so on and so forth. You would notice that the exponents of our variable x would actually be all of them odd numbers. So we expecting here is x to the power of 7, x to the power of 9, so on and so forth. This is its actual form if we're talking about the form of the exponential generative function of this x expression here. Now, in terms of your sequence, this is how it would look like. We don't have here 1, so that's actually 0, and then 1, 0, 1, 0, alternatingly, so on and so forth. Okay, now let's move into implication. What does this imply? Notice here that there is no 1. Actually, that 1, in terms of other understanding in combinatorics, is the possibility of that certain object if it's in a multi-set and you're picking r number of objects to come up with permutations in an arrangement. 1 tells us the number of ways. 1 tells us that it's the possibility of that object not to be selected. Since 1 is not here, it's a guarantee that always the item is selected. Okay? At the same time, we don't have here x squared. It tells us that that same object cannot be possibly chosen twice. Cannot be possibly chosen 4 times, 6 times, all even number of times. However, it is surely to be chosen. There is a possibility that it could be chosen once. It could be chosen 3 times. It could be chosen 5 times. All odd number possibilities, it could be done. That's the implication for this type of expression. And since if you are going to look into that in future examples, you know for sure that all odd number possibilities are there, but all even number possibilities are not there, which also includes the removal of the possibility of that object not to be selected. Thank you very much for watching.